So for this function here, we're supposed to try to draw the graph and complete the table. We should realize that this is linear. That's one thing. And we've got a slope of -2/3, and we've got a y-intercept of 4. And so we're just going to go ahead and plot the y-intercept of 4. The slope from any one point on the graph, we can find another point on the graph just by using the slope, as long as it's linear. And then, so the slope would be, we could either go down 2 and to the right 3, or we can go up 2 and to the left 3. So when you have a negative slope, you can choose which one you want to be the negative. I usually just make sure if the slope is negative, then from the point I just go down initially. So, and I'll go ahead and do that. From this point here, we go down 2 and over to the right 1, 2, 3. And I put another point. Now from this point, I could go down 2 and over 3, or from the original point, like I said, I could go up 2 and then left 3. No matter what I do here, I'm still going to get 2 points on the line, and I'm going to go ahead and just draw the line through those 3 points. I only needed 2 of those points, but I just drew 3 anyway. So there we have the line. So just whenever you solve or whenever you graph a linear function, just go ahead and plot the y-intercept, and from that y-intercept draw or find another point using this slope. The domain and range of a linear function is always going to be all real numbers, because you can, as you can see, all of the x values are being used to graph this function, and so are the y values. The y values are going from negative infinity to positive infinity in the vertical direction. Now, increasing on, as you move from left to right, you can see the y values are getting lower and lower, so the function is never increasing. On the other hand, the function is always decreasing. So from negative infinity all the way through positive infinity, the function's values are getting smaller. We have no horizontal asymptotes, nor do we have vertical asymptotes. The x-intercept, we always want to make sure we solve for x by setting y equal to 0. We let y equal 0, and so we get -2/3 x plus 4 equals 0. Now, if we subtract 4 from both sides, we're going to get -2/3 x equals -4. So the idea here is to multiply by the reciprocal, and we're going to get the reciprocal is -3/2. So we're going to multiply top and bottom, not top and bottom, we're going to multiply the left side by -3/2, so the 3's cancel, the 2's cancel, the negatives even cancel, and we get x by itself. Over here, 2 goes into 4 2 times, and we get -2 times -3 is +6. Now, so 6 is the x-intercept, so therefore 6, 0 is how we write the x-intercept. We could have done this. We could have even found another point on the line by, from this point here, counting down 2 and over 3, and counting down 2 and over 3 means that we found our x-intercept that way. But that's not always going to work, so we have to make sure we know that to find an x-intercept, we have to set the y equal to 0. And then the y-intercept, we already had that. That was 4, so we already saw that. So we write that as 0, 4. We don't have any max or min with a linear function. We have a slope, though. We already found the slope is -2/3, and we say, yes, this function is 1-to-1, because for every y, there's only one x. We already know that because it's a function, for every one x, there's only one y. But 1-to-1 is the question. Can we draw a horizontal line through that graph and hit the graph at only one point? That's what makes it 1-to-1, if the answer is yes. But the reasoning, again, is because if you have one y value, you're only going to have one x value associated with it. So if you know the y, you'll know the x. When you know the x, you know the y. That's 1-to-1.